Nigg Bay, Easter Ross, northeast Scotland. Highlands Fabricators, constructing some of the world's largest production platforms for the offshore oil industry. In 1974, for BP's Forties field, Highland won. During construction in the graving dock, water in the Cromarty Firth kept at bay by a 16,000-ton concrete caisson gate. On completion, the gate pumped out and towed clear for the jacket's float-out. A year later, Highland 2. Not all these structures are self-buoyant float-outs. Some are transported and launched by barge. From the adjacent construction area on dry land, these are skidded out, such as for Chevron, Ninian Northern. Summer 1980. For Shell's Fulmar field, yet another skid out. All of 1,200 tons of a push-pull hydraulic system to get this one on the move. But once underway, a mere matter of some 800 tons of steady pull to ease the 13,000-ton jacket onto the barge. Then to be towed out and emplaced in 82 meters of water. And from Highlands Fabricators at Nigg into this aqueous arena of submarine energy have gone other jackets and other structures. In 1974, furthest north yet, in Block 21112 of the North Sea, BP discovered a field with estimated reserves of 565 million barrels. Magnus. To support the production platform, a single-piece structure was needed, larger than any before. To stand over 200 meters above the seabed, taller than London's Post Office Tower. Brown and Root Wimpey Highlands Fabricators were awarded the contract for the construction of the Magnus jacket. The engineering and planning departments were able to build on their outstanding record of previous achievement and start work at once. Draftsmen began preparing the thousands of drawings for the project, a precise visual statement of every aspect of the jacket. Although when emplaced to stand upright, like its predecessors, the Magnus jacket would be built on its side. A construction flow pattern was established early for what was to be the heaviest one-piece steel structure yet to be installed anywhere in the waters of the world. Never before had any yard been called upon for a structure which would have to stand in over 180 meters of water and be capable of carrying a deck load of 35,000 tons. Special steels were necessary. Fabrication of tubulars for the Magnus jacket began early in 1980. Highlands Fabricators pipe mill at Nigg is a major facility in itself, producing not only the tubular sections for projects like Magnus, but also able to manufacture a wide variety of support for clients right across the entire spectrum of the offshore oil industry. For the Magnus jacket, altogether 16,000 tons of steel were rolled at Nigg. There is a limit to the length of tubular that can be fabricated, even in a pipe mill of this magnitude. In an adjacent facility, sections are brought across and welded together into even greater single lengths. piles and brace pipes of up to 50 meters in length. With most of the completed steel structure to be permanently under seawater once in position, all important is the control of corrosion. Onwards across the yard and into an automatic blasting machine, firing steel grit particles onto the tubular surfaces, every millimetre of what was to be 11 kilometres of Magnus tubulars to be treated, and then painted, the entire structure, all of its 100,000 square metres, covered with coal tar epoxy paint. No fewer than 12 other paint systems were applied to different parts of the structure. Meantime, the structure's junction points or nodes must be manufactured. The first stage, preparation of templates in the layout shop. Highlands fabricators are forerunners in node fabrication. Previous to Magnus, here originated those for BP's 40s, Chevron's Ninian, Shell's Fulmar. And now, for BP's Magnus jacket, 150, ranging from simple ones of a mere couple of tons to monsters of over 100, with as many as 14 stubs for tubular intersections. Tubulars and nodes are brought together in the fabrication yard to be integrated into panels. Complete assemblies to be welded together to make up the Magnus jacket. And throughout assembly, checks by quality control. Another anti-corrosion measure, aluminium and zinc sacrificial anodes, bracketed to every section of leg and panel before assembly and ultimate submersion. More than 3,000 of them. More than a third of all the man-hours worked on Magnus were in the makeup of the main legs. These required hundreds of pre-rolled segments, each a third of the complete circumference. A production line was established where special jigs were set up. Stiffeners were positioned, the segments lifted into place, secured and welded. The completed units then stacked vertically to form the main leg sections. And finally, painted. And while the first steel was being rolled, the graving dock was being refurbished. Thousands of tons of granite were laid to create a solid working surface for the assembly of the Magnus jacket for its brief life ashore. Nigg is accessible by road, by rail, and naturally by sea. Even while the dock was still being prepared, there arrived the first of 20 sub-assemblies built in Japan. This shipment, a total of 3,300 tons, to be offloaded from a Dutch vessel. Shifting these sub-assemblies from the quayside to the graving dock required multi-wheeled transport and much careful manoeuvring. Into the graving dock that early autumn of 1980, marking out as it were the periphery of the base on which would be built the Magnus jacket.
Just check them up for the first. Okay, Donnie, it's looking all right to you.
January 1981. Steel in the air. The first lift. A sub-assembly weighing 200 tons. The elevation -81 panel. Just 3 cranes to handle this, the first of many lifts. In the mechanical and electrical shop originate assemblies of piping of smaller dimensions. Around the 6-inch riser pipes, special anti-corrosive cladding is welded to give added protection against rust in the more vulnerable areas of the structure. This will be the business end of the Magnus jacket. The riser rack to support the 11 flow-line riser pipes which will run the entire height of the jacket, bringing the oil up from the seabed to the production area on the top of the platform. March 1981. Now the jacket is beginning to take shape. Several panels have by now been lifted and welded into place. Already the structure has begun to tower above the yard. The jacket on its side on the firm ground in the dock. Eventually it'll be more than 200 meters long. The welding specifications for the Magnus jacket were the most stringent ever. Before any major project begins, and throughout construction, welding procedures have to be established to guarantee quality assurance, with all required tests carried out on the welded joints. Tens of thousands of sections of steel to be shaped and welded into what will be the Magnus jacket, large and small. Fabrication aids, cut by a magic eye-controlled plate cutting machine. From the fabrication shop to follow, more main leg sections, complete with pile guides. In addition to the yard's already formidable collection of cranes, tall enough to work above and over the height of the jacket, for Magnus came the Transilift, the first of its kind in Britain, capable of lifting and carrying 1,350 tons. By the summer of 1981, the Magnus jacket had become a feature of the landscape. It could be said a landmark, albeit temporary, for miles around. And from miles around came the men who made it. Across the Firth from Cromarty. By road from nearby Invergordon, Tain, Dingwall, Bonner Bridge, Dornoch. Men of the Highlands, now fabricators. Fabricators of jackets and structures for the offshore oil industry. The men who made Magnus. June 1981, another lift. This time a 660-ton leg section, complete with pile guides. 50 meters in length, a main diameter of 6 meters. In a little less than 9 hours, it was up there, in place, 80 meters above the ground. And in parallel, along the dock floor, more main leg sections brought together to form eventually the sealed and buoyant base to support the entire structure during its float out. Now, only 9 short months away.
One small plate.
July 1981. Another major lift. To avoid working at heights as far as possible, panel units are fabricated as large as they can be, horizontally on the ground. Then carried to the loading point, an exacting, painstaking move. To ensure no overstressing of the panel and no overloading of the cranes, the exact weight of the assembly, as well as its center of gravity, has been taken into meticulous consideration. An infinitely careful, most closely controlled operation. By day and right through the night. And then, next morning, at the loading point beside the graving dock, the entire panel to be upended, to be suspended vertically for carrying and lifting into place on the structure itself. Now the transilift crane prepares to take over the entire weight of the lift. Weights which for panels averaged upwards of 400 tons. Effortless in appearance, majestic in performance, an orchestration of forces which is all in a day's work for those highly skilled crane operators and engineers of Highlands fabricators. In appearance, easy, but before it, weeks of planning. One more winter's work yet ahead. Working high above the ever-growing jacket might have appeared to be hazardous, but the safety record on the Magnus jacket was good. A team of safety officers on site all the time, checking every operation. Snow fell early at Nigg that winter, but the Magnus jacket rose above it. Beyond the confines of the dock gate, the cold waters of Cromarty waited to receive it. Less than 4 months to go now to float out. But still another lift, to be planned and calculated with just the same degree of timing and placement as all the others that had gone before. The base section of one of the 4 main legs, to be lifted the height of the structure in its horizontal position. But to be one of the 4 seabed foundations when the jacket takes its place upright in the North Sea. Over 1,000 tons to be lifted more than 100 meters above the ground.
Check out that silver in the cluster.
That this pile cluster, fabricated in Japan, should fit precisely with the main leg sections made here at Nigg is tribute indeed to workmanship and fabrication. Only possible as a result of the extremely high degree of dimensional control exercised throughout the project. Every single weld, and every single welder who worked on the Magnus jacket had to pass a Lloyd's test. Based permanently in the yard are Lloyd's surveyors. And even before the Magnus floatout, steel was being fabricated for the next contract on the order book. Another North Sea structure, a 20,000-ton hull unit, this time for Conoco's Hutton field. Once towed out into place above the offshore field, the process of rotating the Magnus jacket into its vertical position will be brought about by selectively flooding certain leg sections. Installed for this purpose inside and outside the main legs, a remote-controlled hydraulically activated flooding system. And it wasn't all steel. Paper, too. 2,000 and more drawings. 550 structural, 1,000 mechanical and electrical outfitting, 250 temporary works, over 70,000 quality control reports. Imagine what it would be like to install equipment in the lift shaft of a skyscraper, but with the whole structure laid on its side. The upper end sections of the jacket, to be packed with the electronic and computerized control for fuel and water storage tanks in the main legs, later to project above the water. Other highly sophisticated systems incorporated in the structure also call for extensive cabling and complex electrical installations. The Magnus jacket, its scaffolding removed. The scaffolding which was a built-on part of every piece of subassembly lifted into place, so that work could be completed safely high above ground. And what is a dusting of snow for a structure designed to withstand gale-force winds of up to 160 kilometers an hour, and waves sometimes 30 meters high?
Here you go.
But before the jacket can be allowed to leave the dock floor and ride the waters, it must be tethered, moored, port, starboard, fore and aft. As the jacket leaves the dock, the mooring lines will be severed by remote control. The jacket for the Magnus field. Ready now for float-out. The largest one-piece steel structure to be built to date. And that date was Thursday, March the 25th, 1982. The flooding of the dock began that evening. 20 hours to fill. The water rising to the level of the Cromarty Firth, whose changing tides have been kept at bay by the great concrete caisson gate since the first steel was rolled 2¼ years ago. Once the dock was filled, the gate itself had to be pumped dry to enable it to be towed clear.
Tango 1, come on, Kenny.
For the float-out, a good weather window essential. Not just a fine day tomorrow. 5 clear days will be needed to get the jacket out there and reorientated above the Magnus field. A high spring tide, all important. Wind, if at all, moderate and from the right quarter. The level of the steadily rising gate constantly monitored throughout the complex countdown. In the cold gloom of the morning of March the 27th, the gate was ready to be towed clear. No ceremony planned for a float-out this time. No distinguished lady to wish bon voyage and bless all who will work on her. For by now, the float-out of even a structure on the scale of the Magnus jacket is no more than just the successful conclusion, on schedule, of yet another job of work for Highlands fabricators. 9 a.m. and the tugs are beginning to inch her out. It's a tight fit, but the mooring lines keep her on an even pull. For the people of Nigg, and from many miles around, it's a grand spectacle for a Saturday outing. The mooring lines detonate in sequence as the structure leaves the dock. The moment the Magnus jacket cleared the dock and was out in the Firth, it became the property of the client, BP, British Petroleum. Now, ocean-going tugs take over for the 375-mile tow north to the Magnus field. From the yard at Nigg, others have gone before her, and others will follow. For such is the record, and such is the business of Highlands fabricators.